Thanks for coming this evening, the first of our winter lecture series. It's a really good turnout, which is really good to see. It's been a few years, 3 years or so since we've run one of these. So it's good to see people haven't forgotten what a great evening they actually are and hopefully useful. So I'll go through the series of what's up on the screen in a minute. It's also a particularly good turnout because, of course, it's budget night tonight. So maybe it's just this is better than watching hockey talk about budgets, federal budgets. Big thanks to Craig Vinyl up back there and Maddens for supplying this venue, which is a really great venue, close to all the facilities, central, and hopefully we can continue to use it. Probably wouldn't want too many more people in here, but it's working as it is, so thanks, Craig. If anybody doesn't know me, and I suspect there are some faces in here that I'm not aware of, I'm Peter Temple. I'm the head coach for South Australia Northern Territory. Officially I'm the RTO Sports, Regional Technical Sports for South Australia Northern Territory. So my role is to coordinate things such as these coaching lectures, the annual coaching week, and also talk to various coaches and other people from the clubs around the state, and maybe Northern Territory as well, and Northern Territory as well. So I know we've got people here from Adelaide Soaring Club, which is where I'm from, Balaclava, Waikerie, Stonefield, anywhere else? Okay, I'll add to that. In that little box on the tripod just there, we've got Alice Springs. So keep Alice Springs in mind. This is being recorded. The idea is to make these videos available online, so anybody that actually can't make it, I did mention this is organised for South Australia and Northern Territory. It means that those people can be included, or people down from Bordertown or Nelson can listen to it. So welcome guys in Alice Springs. So what we're going to cover this evening, which is the first of our points up here, just these points up there. I'll talk a little bit about the last summer, coaching events last summer, and mostly about what's coming up next summer. I've gone to great expense to have for you here today the President of the Gliding Federation of Australia. So the Gliding Federation of Australia President is going to talk for 5 minutes or so and tell you what a wonderful thing Cubley is doing for you. And then the main feature, no, that is the main feature, but it's not the secondary feature. Most of the time tonight is going to be Terry, who's going to be talking, we can tell you more about it in a minute, but he's going to be talking to you about speed to fly theory, cruising speeds, other stuff to do with cruising, and final glides. I think that more or less covers the scope, doesn't it? In our other sessions, we've got, well, today is a bit unusual. We had to move this from tomorrow to today for other very important matters. But every other month, it will be the second Wednesday of the month. So June through to September, you'll notice the dates there, it's the second Wednesday of the month. So it's easy to remember. We'll meet here. The lectures will start at 7:30 to nominally about 9:30 each evening. And for those that are keen, and we had 20 or so people today that did that, which is great, we also meet downstairs at 6 p.m. and go to one of the local restaurants, it's a Chinese restaurant this evening. And that worked really well and it was great. So, next month we've got Grant Hudson talking on thermal structure and sources. Well, I should actually mention that because we haven't run this winter lecture series for a number of years, I've taken a back to basics approach with this. So you'll see the topics that are on here for this year are to do with what you might call fairly basic stuff. So cruising, thermaling, what causes thermals, interpreting weather. I'll cover flight analysis and wave soaring and using oxygen. Next year, I anticipate that we'll have an extended series of maybe some similar subjects to these, but there'll be an extended series, some more advanced stuff and some different topics as well. So we'll mix it up. So we intend to keep this lecture series going each year sort of from now on. So in June, thermal structures and sources, Grant Hudson, Frank, Johan talking about ridge soaring. July, glider weather forecasting and related stuff. We're hoping to get Alex Wallace and Craig Vinyl has also agreed to do that. Alex hasn't agreed just yet, so we're working on that one. He hasn't replied to my email. Alex, you in that camera? Can you respond? August, we're not sure what the venue will be just yet. We're hoping to be able to get this place as well. We've got TBD, very popular chat talking about climbing, thermaling techniques, thermaling of other gliders. We'll find somebody to fill that slot. I'm talking about flight analysis. September, talking about orographic wave soaring. So that's wave soaring not from shear wave, but waves from, or mountain wave, otherwise call it. Frank's talking about that. And also talking about use of oxygen. So if you're doing mountain soaring, or even in summer if you're flying relatively high, above 10,000 feet thermals, then you're going to need oxygen. So you cover all about that oxygen. So that's actually next season. We'll move on to that in a minute. Last season, what do people think of it as a soaring season? It's good.
Depends where you went.
Well, it was good in the eastern states. What about in South Australia?
Yeah, we're in the eastern states.
January was pretty dead.
Yeah. There were some good days. It was a bit hit and miss. It was not an outstanding summer, but there were still some really good flights done. And the other point is that even if it's not outstanding weather, still go out there and fly. Do as much flying as you can. You actually learn a lot more on the crappy days than you do on the really good days. So just because the weather's a bit ho-hum, still go out there, you still have a ball out there when you're flying. So in terms of the major events that we had last soaring season, we had the coaching week at Waikerie. That ran between Christmas and New Year. It's the traditional coaching week that we run every year. So it was just after Christmas and it was just before the Multipass Nationals at Waikerie. So we had a few extras and additional interest because it was just before the Multipass Nationals. But I was really heartened to see that we had a lot of relatively inexperienced pilots from around the South Australian and Northern Territory as well, clubs turning up to that event. So we had 23 pilots there, which was a really good turnout. I don't know how many gliders it was, but 12 gliders, something like that. What we did as we moved into that coaching week was to put down a set of goals for people in terms of what it is they actually wanted to achieve during that week. And in the main, most people achieved those goals. The weather was quite variable, which again, as I said before, is not necessarily a bad thing. There are some days where, in fact, there was one day where I went out and other people went out on task. So there you go, good on them for doing that. It really, the last day of that week was the best. Most people did anywhere between 300 and 1,100 kilometres that day. There were 2 pilots that did, well, a whole bunch of pilots achieved badges, 300, 500 kilometre distance for the first time, so congratulations to those pilots. And then 2,000k flights were done on that as well, done on that day as well. So it just shows you what can actually be done during those weeks. We will be running a coaching week again between Christmas and New Year this coming summer. Encourage you to think about attending that. The tentative dates are actually up here, 27th of December to the 1st of January. So once again, that's squeezed in between a couple of days after Christmas and the Nationals, which has been held in Benalla this year. So a number of people, myself included, will be offline the Nationals, so we needed to squeeze it in there. Holding that at Waikerie, there was some discussion at the end of the last coaching week about holding at other sites. But I felt for the moment, at least this coming season, we'll hold it again at Wakefield and we address whether maybe we could hold it at Stonefield as a possibility, or Ballard Harbour is another one that was suggested. Again, with some of those sites have their problems associated with them, and Wakefield really is a good site. So those dates are not confirmed yet, and I still need to speak to the Wakefield guys and tee that all up, but certainly that's what I'm planning on doing at this stage. Okay, in terms of the events coming up for the next season, what I've done there is looked at the GFA calendar, which is a really great resource for looking at what various events are happening all around Australia. Most of these are interstate, but some of them are actually in South Australia as well. Women in gliding, obviously targeted at females, is running at Lake Keepit from the 18th to 24th of October, so that's a really good event for women to go and fly together in a sort of a collaborative environment, helping each other for that. There's a coaching week, some respects similar to our SAGA coaching week, being run at West Wyalong between the 1st and 7th of November. Back up at Lake Keepit again, which is northern New South Wales, if people are not familiar where that is. We have the Club and Sports Class National Championships, 10th to 20th of November. Big event after that, the Junior World Gliding Competition, being run out of Narromine. Many of us are assisting with that, and we have 6 juniors, representing Australia in that competition as well. So, yeah. Coaching week I've just talked about, and then the Multi-Class National during the 4th to 15th of January after that. And then if you're interested later in the season, there's a coaching week from the Victorian Soaring Association, VSO stands for, which is being run out of Horsham. You'd have to contact them in terms of how happy they are for interstate people attending their coaching week, but I imagine that would be fine and would certainly be very, very valuable. And then Horsham Week, which is a competition, runs immediately after that at Horsham, of course. It is a competition, but it's a very low-key, friendly competition, so it's a really great place to actually kind of start out. And there's also a full-on competition after that, which is the New South Wales State Championships, which is quite late, in February, beginning of March. So as you can see, there's a huge number of events already on the calendar. And then down here, I've got a few more that are not on the calendar yet. I'm imagining there'll be a South Australian State Championships at some stage. TBD, we might actually discuss that. There's a SAGA meeting this coming weekend, so I guess that'll be one of the things on the agenda for that is to win that coaching week. That State Championships will be run. In previous years, G. Dale, who is a English coach, has visited a Tour Australia, visited a number of the clubs, and it's been really fantastic in terms of passing on some of his skills and doing some coaching. Unfortunately, we missed out on that. South Australia missed out on that last year, so I'm very keen on making sure that we do get somebody to tour South Australia this coming season. It probably won't be G. Dale, because we're feeling that, as in the National Coaching Panel is feeling it's time to give somebody else a go with that. But again, that's something that we'll hopefully decide on in the next month. I've got a meeting June long weekend in Melbourne, and one of the topics for that is planning in terms of trying to get somebody to all around Australia, but also to South Australia. And then last year, there was an Australian Institute of Support Masterclass. At that masterclass, a number of us were at that. We had Brad Edwards and Ingo Renner giving, the main topics was the two of them with a question and answer type session, which ran for quite a few hours and really was a fantastic session. That, by the way, the sessions are available, the videos are available on the GFA website. So if you go to the GFA website, on the top where it says videos, the videos of that masterclass are up there. And also associated with that event, we had Institute of Sport people talking to us about sports psychology and nutrition and all those other aspects that those sports experts talk about, which was great. I'm not sure what's happening with regard to that this year. The intent was to hold a similar sort of event in about the September timeframe this year. I haven't seen any details of anything yet this year, but keep your eyes open and ears open for that. So as you can see, there's an awful lot, coming up.
Peter, I went to Speed Week last year, and G. Dale was in the seating part of before Speed Week, but there was also Paul Mann gave a very good presentation with Ingo Renner and Brad Edwards. So we had a similar sort of process there, and then we just did competition fine. It was excellent.
So you have a big choice of things you can go
this
to.
year too.
I'd love to actually get, Brad or Ingo or somebody out to our coaching week here in South Australia. Whether I can achieve that's another matter. But of course, if you go to some of these coaching events over in the eastern states, you have a better chance of actually getting some talks from some of these coaches, which is great. That's about all I had to say in terms of kind of introduction. Did anybody have any questions on any of this or any of this works?
The two-seater nationals will probably be held the week after the Horse at Narrabri.
Yes. Okay, so if you didn't hear that, two-seater nationals in February at Narrabri, just here, so it'll be mid to late February. And a number of us, Brian, Graham, Terry, myself, have flown in that event numerous times in the past. Okay, moving on. I'll introduce you to Mandy, who is the Gliding Federation of Australia President as of a couple of months ago.
Excellent my memory.
Tell us all about what GFO is about.
Wow, there's a lot of people, isn't it? So I'd never actually expected to be here in this position. It's all happened very suddenly. Just going back to last July, I was still chair of the sports committee, and I was very happy being chair of the sports committee. I quite like that. But at the August meeting, which was in Adelaide, Anita Taylor resigned, and John Summers, who was the vice president, became the president. And I was asked to become the vice president, and actually Marta then stepped up to become chair of sports committee. And that was all fine, and we were all going along fairly well, and I was working out what was going on. And then 13th of March, Friday the 13th of March, actually John unexpectedly and rather suddenly resigned, and here I am. So that's how it happened. It's interesting with the GFA and the membership, there's this sort of that poor relationship, history of poor relationship. And if you'd asked me 20 years ago or even 10 years ago, what does the GFA do for gliding? I would have said, well, there's a bunch of people and they go to Melbourne and they have a lot of meetings and they talk to CASA because CASA won't talk to glider pilots, and they charge me money and they make rules and they've got a crap website. And that was sort of what I thought about the GFA. And I hope we've come forward a little bit from there, but I imagine there are still people out there that don't really know what the GFA does. And I think part of what I'd like to do while I've got an opportunity, not just here but over the next couple of years, is try and explain to people how diverse the things are that we do. There's just a huge amount of work that goes on behind the scenes that nobody is really aware of. And it's partly our fault that we're not telling you, but it's partly that we're so busy doing it we haven't had time in the past. At the moment we're kind of in a bit of a golden period. I don't know how long it's going to last, but membership numbers are climbing. CASA think that we're nice, that we're good. I think RALs have helped us there a little bit because RALs are sort of not being the best. I don't know RALs members here, sorry Bruce, to you RALs. But they keep crashing and they keep resigning and their committees aren't really working. And so CASA think we're in a good place, so that's helping. So we're actually in quite a good position to do stuff for the members. I've been on the board 3 years, and in those 3 years, most of the time, we spend all our energies trying to keep CASA off your backs so that you guys can keep flying. You know, we've come this close to being everybody grounded more than once. And it's just been a huge job to get that all sorted out and to make good relationships with CASA, and Anita had a lot to do with that. So I'm going to just use this as an opportunity to do a bit of a straw poll. Who that's here at the moment is actually signed up to OSSoaring, the online chat OSSoaring? How many people are signed up to OSSoaring? 1, 2, 3, 4, 5, 6? No? Anybody else going to confess? Just 6, okay. How many people are signed up to the new Gliding Australia forum?
We tried.
No, that's not working, is it? Okay. Okay.
So?
How does Google Plus work?
You don't need Google. You don't need to use Google.
That's what comes up. It comes up
Okay, we need to do a bit better work. So we've started a new forum. Soaring was a forum for chatting amongst the members, and when it started it was really good. Towards the end it became a little bit taken over by bullies. It became a little bit poisonous. It wasn't very nice. So this new one is supposed to be a bit friendlier, it's moderated, and it's supposed to be easy to join, but...
But that sounds like we had a similar thing that came up. You had to join Google, put your Google number and all this sort of stuff. No, I just gave up.
No, you don't. Just click me an email, I'll get you joined up like that. If anybody wants to join up, just send me an email. My email's on the GFA website, and we'll get you joined up, because there's 350 members already, which is more than Soaring ever had. And we're having some quite interesting conversations about waveline and VNE runs and toss strings, and some people find that interesting. So we're going to put some news out there as well. But the idea with the new website is that we can interact a little bit. With Soaring, when anybody official from GFA made a comment, we just get shot down and torn to shreds, and it got very personal. So it's very difficult, and we just step back and refuse to comment. The new forum is our forum, so we can respond. So if someone asks a question, you know, what's happening with annual flight reviews, when's the next Form 2 course, what's happening here, what happened there, we can actually come in officially and give you a proper answer. So if any of you haven't signed up and would like to sign up, just flick me an email, or maybe if you look on the GFA website, I think it's under My GFA or My Membership, down the bottom there's a link you can click on, and that should just sign you up straight away. You don't have to log in, you don't have to join Google, you don't have to do anything like that. So maybe the Google sign's a bit bigger than click here or something, but there is a way of doing it without any. Maybe we're looking during the break. Okay, so that isn't working. What's been interesting is that as president, I've decided that what I will do is phone every club president. We've got 72, and I thought I'd introduce myself to the presidents and sort of talk about issues on the ground and find out what's actually happening at the club level. And the really scary thing was that of the first 5, 3 of them thought that Anita Taylor was still president. I'm glad you laughed, nobody else did. But that was quite useful actually, because that made me realise that people actually aren't that interested in GFA, and that's a shame. So I want to try and improve that relationship and try and get you guys excited about GFA, because there's a lot that we can do, but it needs to be done in partnership. We need to know what you need. You need to tell us what's going on. I get so disappointed when I see something on Facebook, look what GFA did. GFA did this, and it's a simple mistake that one side or the other has made. If someone just phone the office or contact me or Terry, we could fix it. But they put it on Facebook, look what GFA did. So I get very disappointed. I take that quite personally when people do that. It's difficult that we can't fix problems if we don't know about them. So we are keen to fix things. If something isn't working, we want to know about it. We've implemented a whole load of new web-based systems, so we're getting more efficient. Just last week, Tim Shirley's come up with a system now where you can push a button and it'll produce a Form 2 kit electronically that we can email out to you. So rather than the girls having to go around and pick up ADs and maybe getting the old version or missing one, it's all done electronically from the central database, so it's unlikely to have any errors in it. So there is a lot more stuff that's happening automatically, which should be better. We have a nice database called Salesforce, which is getting to be a bit more robust. As we go through the first 12-month cycle and people start to renew, we'll find out where the errors are and where the gaps are. Because when you get your new membership card now, if you've got a GPC, it actually is a GPC card, and it's combined with your membership, and on the front you've got your ratings. So it'll say you're an AEI or an instructor or level 2 or airworthiness qualifications are all on the membership card. If those qualifications are missing, that's because our database is missing that information. So when you get your new card, there's a little bit of a sheet and it explains the process, and if the data's wrong, then you just get onto the website and fix it up and we'll send you another card. So we're still going through the process with that. We're still sort of, the first 12 months I guess is where we're sort of settling everything down. Some of it's good and working well, some of it's not working so well, but I do urge you that if you find a problem, like if you can't sign up, just flick us an email and we'll fix it, because it's easy to do. So who's going to join up to the forum now? Try. 4. Oh, great. Good. That's great. Good.
It probably is worthwhile if we just, during the break, perhaps if we actually go find the email and click on it and go through it with people as to how to actually do it.
Must be,
tutorial.
I didn't put a lot of time into it at the time. I just thought,
Well, it should be dead
and then
easy.
I don't keep my heart.
You do need to Google.
I'll look at it later.
No,
No,
you
no.
don't. No, you don't. No.
No.
So ask me for mine.
If you've got one, it'll use it.
If you've got one, it'll ask you
Yeah.
for it, but if you haven't got one, you don't, So, but you don't need to use it. But we can fix it. We'll fix
So how were
it.
we first told about the existence of the Gliding Australia Forum, because I didn't know about it.
Okay, so there was an email that came out from Terry, went to all GFA members. Do you not get that?
Last week.
I probably got lost in my emails.
2 weeks ago.
Week before last.
I mean, that's the problem we've got. The presidents that I was talking to, the presidents you think might be interested, they didn't know the president, changed, and we're sending out emails, and there's the magazine, and there's the website, and there's like, so I'm interested to know, what you guys think. If we should be sending out more emails, should we be sending out more messages, or should we have more forums? Are you kind of snowed under and we're spamming you and you want less? Or do you want more? Because it's hard to get the balance. Clearly the message isn't getting out, but you guys didn't know about the forum. The presidents didn't know about the presidents changing. You didn't know about the form. And yet some people go, oh no, stop your spamming us. So we're always worried about getting the balance right, but we know that we're not really getting the message out there. So let me know what you think. We are going to be running some more airworthiness courses this winter. Those of you that have been around a bit longer will remember the National Gliding School. We're going to sort of reinvigorate that, so it'll be the National Gliding School on steroids, because it will be ops as well as airworthiness. And it'll be like Open University. There'll be little modules that you can do. It won't be all centralised. And so for the airworthiness, Pete Sesko, who's South Australian and is now the Vice President, so we're gradually taking over the board, he's talking about doing some modules that will be on wiring, some that will be on microphones, some that will be on pneumatics and things like that. So private owners or anyone that's interested can just be upskilled a little bit with how to do those things. Because no training's been done for many years in South Australia, so we are really, really keen to get that going. I think you might have seen an email asking for interest in courses. I think we had 300 responses, people that wanted to do a Form 2 course, so that was really good. Rob Hambry's putting that together now with Pete Sesko. So if you haven't responded and you are interested in doing some airworthiness training over the winter, either let Rob, who's top of the airworthiness, or Pete Sesko know, because they're putting lists of names together based on the responses they had to that initial email. So during the break or later on, if anybody's got any questions or any feedback, then I'd welcome it. Thank you.
So what we'll do for the remainder of the sessions today is that I'll introduce Terry in a second, and he's going to start talking about his cruising. At some time we'll take an opportunity to take a break. There'll be tea and coffee and I've been pulling some cookies down the back there.
Chocolate biscuits.
Chocolate biscuits apparently.
Maybe while Terry's setting up, everyone can kind of just push in that way. We'll move these tables out of the way, and everyone at the back here can push into where those tables are. So everyone on the side there, we can all down that way.
You're very transparent.
You've got a shorter chair than me.
Okay, now that we've finished rearranging all the furniture, it's actually great that we're having a trouble with our furniture here. It means that there's a lot of people here, which is really good to see the number of people who've had coming here. Yesterday I asked Terry to give me a brief bio for his background, because I thought that would be of interest to you, and I'm actually quite surprised it's how much is in there. A brief bio, and I got a page. And I looked through this page and I thought, it's pretty hard to exclude much of that, and I just wanted to, touch the high points, but they're all high points. It's pretty damned amazing what you've actually done. Started flying in '68, just fairly young now, I won't say how young, don't give the age away. And then if we skip over club responsibilities and things like that, in the national roles, he was chair of the GFA Sports Committee for most of the time, between 1985 and 1999. I'm assuming it's during that period of time he introduced the concept of sports coaches, which is really advanced gliding as a sport in Australia as opposed to just being a hobby. He was the GFA Treasurer in 1990, GFA President for 3 years, 91 to 94. Chair of Marketing Development recently, that's GFA Marketing and Development, and he's the current GFA Executive Officer. He's had quite a lot of international influence in the International Gliding Commission, who is the body that oversees gliding across the world, sporting elements of gliding. He's been an IGC delegate since 1998, which means he gets to go to their plenary meetings every March, typically, somewhere around the world, mostly in Europe. He was the World Championships, was the Championship Director for the Gawler World Championships in 2001, right? And related to that, that was the first of the World Championships that had club class as World Championship class, and Terry was instrumental in actually getting that introduced as a new class type for World Championships. He's had a very strong role in terms of winning 3 bids for World Championships for Australia. That 2001 World Championships in Gawler, and also the 2015 and 2017 World Championships. 2015 is the one that I mentioned before, is the Junior World Gliding Comps at Narromine, and the 2017 is the Flapped World Gliding Championships, which is 15 metre class, 18 and open, which is in Benalla in January 2017. And also was instrumental in the development and introduction of the Sailplane Grand Prix, which is a relatively new form of racing. It's a Grand Prix style scoring system where effectively the first place getter gets a certain number of points, and then the next person back gets 1 point less, etc. So it's just number of points is based on the placing. So and that's quite a good initiative in terms of introducing that. In terms of his flying, he's an active instructor and coach. He's got just under 6,000 hours of gliding, which is not too. He's been the national champion 5 times, with a 1,000-kilometre diploma. He's represented Australia in 7 World Gliding Championships, just 1 or 2. Owns an LS3, but also enjoys flying in twin-seaters. So you can see there's a lot of experience in there, and a lot of really relevant experience to our coaching talk tonight. So over to you, Terry.
Thank you. I actually enjoy talking at these sorts of presentations. One, it means I get to talk a lot. People have to listen, which is nice. And the topics we got here, polar curves, speed to fly, etc., is probably the better side of my skills in terms of the whole cruising bit. They don't get me to talk about thermaling too much, but I'm better at cruising than I am at thermaling. It's quite a broad range of topics. We could spend hours and hours on that, but I'd bore you to tears. So I'm just going to touch on a number of things, but if there's things which I start to talk about through that I skip over or I move on too quickly, just let me know, because I can give you some more detail behind that if required. So there's a little bit of theory behind this in terms of polar curves. We'll break that down. There's a little bit of mathematics there, but I promise not to focus too much on that. And we can see then how that is put into practice. So I've got some data, some measurements, etc., which I've done for myself flying the LS3. So this is a little bit revealing. And I've also done some statistics. I was doing some coaching with the world team in Uvalde. So I was collecting a lot of statistics each day about their performance. I got some of that data to show you that the theory actually does work in practice. And then how can you do better than the theory says? So that's the intent of the whole thing. Cruising considerations is a huge topic in itself, and I'm just going to touch on 3 or 4 items of that. And the final glide, there's 3 or 4 things which make a big difference in final glide. And so depending on whether you're trying to just get home or whether you're trying to win a national championships or a world championships, you'll approach it differently. And there is time and points, and also safety is paramount in terms of doing that properly. So that's broadly the topics that I've got. Yeah, that works. When it came to, I thought I can draw pictures on the board, but I'm not a great drawer. And so I looked around for polar curves, etc., and I came across this particular one, that reference. So if we actually put this presentation on the web page, people can click on that and see it, which is an American training package looking at polar curves and speed to fly. So I thought I'll just play you that one and that will do us. I also found then another good site which has got real polar curve data on it, so we'll show you that as well. So what I might do is go across to the American thing. This is one of the diagrams that we'll see in a second. Now Americans being what they are, they talk about a glider called a 126. So if you think about the Junior, or you think about a little Grob, or you think about, maybe K8 is probably close to it actually, for those guys from Stonefield. So this is a very low performing glider. So they use that, and they've got pretty colours, so that's okay. And this is trying to show the performance of the glider. So we'll I'll just click over to that particular site. If I can do this. So this is the Did I do something?
Press F5. Sorry.
F5?
F5 often does it.
Shift F5.
Oh, you've got it on there, but not on there.
You just drag it across.
Alright.
Turn the screen.
Now let me go back to the presentation. Is that there?
No.
Okay, so
Broken.
Oh, you've got your desktop. So it's
It's there.
yeah.
It's something on the laptop.
Well, Windows key, the Windows key and P. Try that. If that's a Windows machine, isn't it?
Yeah.
Windows key P. There might be some options for sharing, duplicating, anything.
Duplicate.
Yeah.
Duplicate, then you see what you have there on there.
Yay!
Oh, who made that name?
Yeah. No, no.
That work?
Mm.
Yeah, okay. Well done. We'll give you your entry fee back.
Oh, thank you. No charge today.
This is the FAA site, and I'll scroll down in a second. It talks about this 126 glider. You'll see cruise speeds of 26 and 31 knots. Okay, so it's pretty slow speed stuff, and it glides. And it talks about these four gliders, and you'll see at some point they all start from up here, then they all fly off for the same amount of time, and the red one goes really, really fast at 60 knots, and the green one does that. So they all fly down, and it creates basically a polar curve. A polar curve is a graph showing the speed of the glider and how fast it sinks at that speed. So across the horizontal axis here, the speed going from 0 to 60 knots, and then here's the sink rate. So when the glider is flying at 40 knots, it's sinking at just about 2 knots. It's about 1 in 20 glide angle, by the way. If it's flying at 60 knots, it's doing just over 3 knots of sink. Now you can get these polar curves for every glider. This one's a fairly low performing glider. We've got other examples for a high performing glider, but it's the thing that describes how good a glider you've got. But it also provides us with other information. So it's where it's landing, and we can get a range of bits of information coming from this in terms of the glide angle and in terms of speeds to fly. So I'll come back to that because it's quite useful. And I'd say I've got the reference there, and if you want to go through it and read all the writing, etc., it's worthwhile. So I'm just going to do a bit of flicking around. I'll do. Bear with me. You do?
Yeah.
Oh, good stuff. So you see, this is their polar curve. The key measurements on here are the minimum sink speed. So the minimum sink is when it's got the lowest sinking rate, and it's about the green one. All right, so that's as close to 0 as it gets. So the green one, it's sinking at about 1.6 knots or so if you follow the line along. And it's doing that at about 30 knots. So that's the minimum sinking speed. If I go the best LD speed, and the lift-over drag is actually created from a line. If I draw a line, it's about the speed divided by the sink rate. And if I draw a line like this, it just touches that polar curve about where the yellow glider is. So the best LD of this glider is about 20 or something or other, 40 to 2 knots, so about 1 in 20. Gives you the LD of the glider. If I fly faster, then the glide angle is steeper. So if I go to the red one, that is a steeper line than if I go to the yellow one. And even if I go to the green one, it's steeper. So this is the optimum glide angle where the yellow one is. If I fly slower than minimum sink, on this back end of the curve, you'll see its rate of sink is higher, and it also doesn't glide very far either. Its glide angle is about here, so there's no point in flying at those sorts of speeds. So that's what a polar curve is. Now there's a whole heap of information we can get from that. Any thoughts or questions on what a polar curve is? Does it make sense? You understand what it's telling you? Obviously. LS3 polar curve. And I'll use the LS3 because that's what I fly. So does Eric. Or will be. And actually there's a few of them at Gawler, but it's very similar, as we'll see, to a number of other gliders. So this is the polar curve of the LS3. It's actually the red line here is the polar curve, and you'll see its best glide angle, this is the green line, is where from here just touches the axis at about here, is around about at 57 knots, and it gives you the numbers here. 56.4 knots is the best speed, the best glide angle, and the sink rate, so its glide angle is 1 in 40, so it's twice as good as that 1 in 126 glider. So the LS3 will cruise along that. If I fly along at 55 knots, it will give me that glide angle. If I fly a bit faster, it'll give me a much steeper glide angle, but I'll be getting there quicker. So that's the compromise. In terms of the minimum sink is the speed at which the glider sinks the least amount, about there, and at the top of the line, and that's about 1 point something knots of sink, and it's around about the 42 knots, so 1.2 knots at 42 knots is the minimum sink speed. So the question is, if I want to fly this glider the maximum distance, so the day's died, here I am out at Waikerie at 10,000 feet, and I want to get back to Gawler, will I make it? What speed should I glide at to maximise the distance I can achieve? Any thoughts on that?
Depends on the wind.
Yes, zero wind. Just make it easy for them.
Or best LD.
Best LD, which is on this one 56 knots. So if I fly for 56 knots, I got the best chance of getting there. If I'm in a thermal climbing, then what's the optimum speed? And we'll talk a bit more detail about it. There's a few other factors. What's the sort of speed I should be flying at to make the glider climb faster in the thermal?
Minimum sink.
Minimum sink, because the glider's actually sinking through the thermal. The thermal's going up like this and the glider's sinking down through it. Luckily it's going up faster than we are, and therefore if I fly at a low speed around about the 42 knots in this glider, there it is, 42 knots in this glider, its minimum sink speed is less, and therefore it will probably climb a bit better. So there are some other considerations which we'll look at in a minute. Now, I've actually got this polar curve from that particular web page, and what it gives to you is a Excel spreadsheet, and it's got a whole heap of, let's see if we get this to work this time. It gives you a whole heap of polars.
So that polar would be changed a fair bit by ballast though?
Yes. So if the glider's heavier, then it will sink more. If
You know what to do, Windows key P, give the beneficiary.
Windows P.
Yeah, and then you have to select what you want.
Terry, is there a mathematical equation that you can apply to any aircraft to derive the polar curve, or is that?
There's a, you can define the polar curve mathematically, and this blue line here that you can see on there is a mathematical estimate of the polar curve of the LS3. And you can see it's not too bad, it's not too far off. It gives you a very smooth shape, obviously. They get that by putting in actual data from the glider and then feeding that back into the equations, and then it spits out that at the other end. So for each of the gliders on this list, there is a blue theoretical polar. And that's useful for a lot of instrumentation, which derives what speed to tell you to fly or what you're doing in terms of performance. It derives some of that from those maths. It's got a simple curve which describes it. It's much easier mathematically to do that. You'll see the red line here has the red line varies a bit from the blue one. There's a bit of a dip in here, right through here, at about 60 knots. That tells me that if I fly at 60 knots, the glider's performance is going to be sinking more than it really should be. So I want to avoid 60 knots. So I shouldn't fly at 60 knots, it's a waste of time. I'd be better off to go faster to get a better glide angle. And down here at the 80 knot, 85 knot range, then it's I'm actually doing better than the theoretical, and that may be a nice sweet spot to glide at reasonably often. So that gives us the data for the LS3. This spreadsheet's got a whole heap of gliders in there. If you want something different, well, let's compare it. We can compare two gliders. Let's say I compare it to a Stanley Bell. There you are, Bruce.
Thank you, Terry.
Okay, so the green line is a Stanley Bell, and you can see a Stanley Bell is not as good as a Jantari, sorry, a LS3 in terms of performance.
Oh no.
And for all these years you've been thinking it's better. So you can see it at higher speed it loses out, even at the low speed end. The thing is it is very light, and therefore it goes quite small circles, and therefore it
Discus B.
yeah.
So is there $1 per knot calculation?
Standard Cirrus, PW5, that's an interesting one. LS4, was discus.
Quite interesting polar on there. See if that's the
Discus
same
B. The discus B here is at 29.7 kilos per square metre, is a bit light. Discus A at 32, let's use that one. Again, the green one there. It shows that the Discus 2 and the LS3 are very similar in performance at this slow end. In fact, the green one is fractionally better at that slow end, but at the higher end it drops off. So if you start cruising now at 80 knots, the LS3 is going to be sinking at 2.2 or something, and this one's going to be closer to 3. Right? So it sinks a lot more, and you can see that in practice. Now it depends on what wing loading you're flying it at. Right? The wing loading here is for the LS3 is 35.5. Now I actually can't fly my glider at that wing loading. Wing loading is how heavy it is compared to the area of the wing. I can't get mine that light. It's a heavy glider and I'm sort of heavy-ish. So my typical wing load is around about the 40, 41. The maximum is 45. For the Discus, minimum wing loading is a lot lighter, so it can get down to there, but its maximum is closer to 50 kilograms. So if you put a lot of weight in this, then that'll make the Discus a lot closer to the LS3. So we can look at how that is impacted. There's a calculation which I do a bit later on. If you want to see what happens to the speed, it's the wing loading over wing loading, and it's the square root of that. So if you've got a maximum wing loading for my glider is 45 kilograms, or you could use the actual weight, which is 475 kilograms. 45 kilograms per square metre, and the minimum here is 33, something like that. No, 35. You divide that into that, then find the square root of it, And the answer is 110%. So it says if I want to change these numbers from 35 wing loading to 45 wing loading, then I need to multiply the speeds or add another 10% of the speeds. So for this indication here, instead of flying at 57 knots, I should be, the best glide angle is actually add 10%, that's 56, 60, about 63 knots. And the sink rate is also plus about 1.4, 1.5. So you can multiply those numbers by that percentage and it will show you what the numbers are for that other speed. This is, as I say, a nice diagram because it gives you the comparison with a range of other gliders. You can't find anything newer than about a Discus B or an ASW24. So it's an old one, so you can't find some of the more modern gliders on that. Any questions about what the polar curve is telling us from that perspective? And I'll come back to this diagram. There's some really good information in some of those other worksheets down the bottom. We'll look at them in a few minutes. Stay on this for a bit. Yep, there it goes. So there's the data. So we mentioned thermaling before, and what's the optimum thermaling speed? And theoretically, you'd say the minimum sink speed. So for my glider, about 42, with my weight in it, with water in it, that becomes about 46, 47 knots. So I should be thermaling about that sort of speed. If I do less than that or more than that, it sinks a bit more. However, what happens then is that instead of flying along like this, we actually bank the glider and go around in a circle, and therefore you get a higher G loading, and therefore the stall speed and all the other speeds increases as well. So 42 knots, let's use the bottom numbers, 42 knots is fine as long as you're not putting much bank on, but if you start putting a bit more bank on, you actually need a little bit more speed. For a couple of reasons. One is that the stall speed goes higher and therefore it's safer. You're not going to be stalling all over the place. Secondly, its rate of climb will be better. Now the problem with slower speed is it's less manoeuvrable. If you try throwing a glider around in a broken thermal when you're at very low speed, you can't do very much. If I want to fly at a steeper angle of bank because the thermal's a bit narrow, as in most of South Australia, then the higher stall speed requires a higher speed as well. So the optimum thermal speed will depend on what you're doing, but it should be based something around the minimum sink speed plus allowances for these other variables. So it will also vary depending on what wing loading you're flying the glider at. So for my glider with full of water at 45 kilograms per square metre in about, say, a 40-degree angle of bank, I probably need to be something like 55 knots rather than 47, somewhere between 47 and 55. I tend to fly a bit fast, it's probably a bit better, a bit slower. So you can have a look at your glider at the rate of sink, and that gives you some idea about thermal speed. What are people's experiences in terms of flying their gliders in thermals? What sort of speeds are you operating at? Think empty or think full? Just declare that.
50, 55, depending on the angle of bank.
Yeah, and what glider is that in?
26.
26. So that's round about the 40 kilograms per square metre wing loading, so it's not much heavier than that.
Just so you've got better control over the aircraft.
Yeah. So the controllability becomes important.
When it's smooth, you can go slower.
Yeah. Yeah, so if it's a smooth thermal, then you can fly a bit slower and you get the speed back and utilise a bit less bank. You can actually utilise that low rate of sink. Other experiences. Bruce and your Lavelle?
I try for 45 degrees and 45 knots,
Okay.
and I can't do. I'm not that good at it.
Right. So again, that's probably erring more towards the back end of the polar curve at that point because of the angle of the bank.
Yes.
So they're the sorts of numbers that people are talking to that make sense. Okay. Now then, back in the good old days, even before when Bruce first started to fly, and probably back when I was starting to fly. They were just getting over it by then. The aim of the game was you climbed up high, and then you glid off at, I don't know if they understood best glide angle, but they glid off at probably just a bit above thermaling speed. So now we're talking about gliders in those days similar to the 126, so you're talking at 30 knots, 35 to 40 knots maybe, and they climb up like a cork in a bottle, up it goes, and then they glide off at 40 knots as well, and having a nice time. They never got really low. Well, actually the glide angle was a bit like, instead of being like that, the glide angle was like that, so they were getting low. It was a bit like a hang glider. So those things operate at low speed and they don't cruise off too fast. So that was the idea. A guy named Paul McCready he's a mathematician, he started to do some calculations, and he worked out that in actual fact that's not true, because it's not the optimum. You actually need to fly a bit faster. So what he found is that if we've got to take two gliders, the blue one, which is doing the I fly off slowly and have a nice time, I don't get very low, that I don't scare myself too often, and I then climb up in the next thermal. They probably work most thermals because the glide angle is short. The gung-ho ace in the stuck the stick forward and actually went a lot faster, of course gets lower because the glide angle at 80 knots or 90 knots is a lot steeper. So at 40 knots you're here and at 80 knots you're like that. The glider's plummeting earthwards, but it's also going forward relatively quickly. So a couple of examples here for an LS3. 56 knots, sinking at 1.38, that's the best glide speed I had before. Or I can do the same flight cruising off at 87 knots, and of course I'm sinking more. If I go 36 kilometres, and I think I chose that because I can't actually remember. If I go 36 kilometres, this glider takes 21 minutes, so the blue one cruises up here nice and slowly, and gets there 21 minutes later. All right, that's a nice view. The orange one goes a lot faster and actually gets to the thermal after nearly 14 minutes. So 7 minutes earlier, 2/3 of the cruising time. So already he's 7 minutes ahead. However, he is lower. Right, so this glider has lost nearly 3,000 feet and this one's lost nearly 4,000 feet. So cloud base is 4,000 feet. This one will get there at 1,000, this one will get there on the ground. So there's a compromise there somewhere. But this one loses 3,000, this one loses 4, and the glide angles are 40 and 30. They then have to climb up in a 3-knot climb. So this glider he's only got 3,000 feet to go, so it takes him 9.6 minutes, this one takes 13. So he's not quite as quick. But the total elapsed time from here to the top of the next thermal is 30 minutes for the slow glider and 27 for the faster glider. So there's some advantage in flying at the highest speed. And the average speed achieved is 80 kilometres an hour versus 72. So both of them get there, both of them have a nice flight, but the faster one is going to be doing it more efficiently and quicker. So flying off at best LD speed, unless there is no more thermals, this glider, if there's no more thermals, this one will land out further away and we'll get back closer to home, this one will land out quicker. But if there are thermals and your expectation of thermals, then it'll get there quicker. What are your thoughts on that? Does that make sense? Is that what you do?
Try
To do it, yes. Yeah. So so I'm talking here at 60 knots versus 90 knots. So how many of you cruise off at 90 knots in your glider? You do, yeah. Frank always does.
No.
It's not too slow with the SGs. The Bell's probably pushing the boundary. When you look at that polar curve, it drops off. So it depends what glider is as well, right? So there are speeds for each glider.
How fast the discus on?
Yeah, fraction fast. I think the discus probably around the 85 or 90 is probably the optimum. But it depends again on wing loading. This is assuming low wing loading. So we'll have a look at that because you can do some or you get some advice and calculations which shows you how fast to go. So what's the optimum? In that last calculation, I said if it's 3 knots to climb those heights, if you've got a 3 knot climb, the fast one would get there quicker. However, if you only got 2.5 knots, so the thermal wasn't quite as good as you expected, so you get 2.5 knots, then the slower glider actually ends up getting to the top of the thermal quicker, because it's going to take this guy, the numbers right, he's got to go 4,000 feet, he's going to, at 2.5 knots, so it's 16 minutes to climb the height, so it's going to take him a fair bit longer than this guy who's only got 12 minutes against that 4 minutes difference, which is about only just about the same. So if the rate of climb is not as good as you thought, then you pay a penalty by flying fast because you end up starting lower. So it's based on, the theory says if you know what rate of climb you're going to get in the next thermal, then you can select your speed to fly. If you know it's going to be 2.5 knots, I should fly a bit slower than 85. I might want to slow it down to 80, 78. If I'm going to fly fast, if I'm going to get a stronger thermal, then I can stick it up and get there at 95 knots or something. So if I know what the next thermal is going to be that I'm going to take, then you can select the speed accordingly. So what's wrong with that theory? You don't know what the next thermal, who knows what the next thermal strength is going to be? Bingo, yeah. In a sense somewhere. Okay, so you're making a guess as to what you think it will be. That will then dictate the speed you fly at, and if you guess wrong, then you can either keep pushing until you get your 3 knot climb, which is the preferred approach, as long as you don't bump into the ground. Okay? So somewhere along the point you're going to say, actually, I'm going to take the 1 knot climb now because I've been a bit silly here. And staying up is important. If you don't reach the next thermal, then your flight is over. That's the end of the story. That's how it works in gliding. Okay? So that's in the back of your mind if I don't get there. If you don't expect to find any more lifts, so you look ahead and go, actually this day is dead. I want to get as far as I can, close to home, less distance for the crew to travel, then the best LD speed is best. Is minimum sink would minimum sink be better than best LD?
The tailwind, yeah.
Okay. So it depends what the wind is. Why is the minimum sink better with a reasonably strong tailwind?
They have longer, therefore the wind has more time to get you there.
Yeah, so the slower speed. And you can actually see that on the polar curve. Have I got another polar? Yeah, I've got another polar curve coming up. So the polar curve provides some answers to that. So there are occasions when the flying slower than the expected climb is, and that's to do with winds. Headwinds or tailwinds do have a bit of an impact on where you meet on the polar curve, but it's not a huge difference. Now this is a sort of composite diagram, and because what we're now going to do is, so in actual fact there are thermals in the sky that we're flying in, and we want to make decisions based on what the thermals are doing. So to do that with this thing, here's the polar curve, and it says that I'm sinking at 1.2 knots or something below 0. I'm sinking 1.2 knots. If the air is going down at 2 knots and the glider sinks at 1.2, how fast is the glider going down? 3.2. So it's got the sink of the glider plus the sink of the air mass. The Macready's theory was based on that if you got 3 knot climbs, then you're going to get an average of 3 knot sink over the duration of the flight. If you've got 6 knot climbs, you're going to get more sink. So it'll be closer to 5 or 6 knots of sink. So his theory is based on what we're doing here with 3 knots is I'm actually moving this 0 place up to 3 knots. And now I draw my lines from there. So here I am at, in still air, that's best glide angle, 1 in 40. If I'm now flying in 3 knot climbs and getting a corresponding sink, the glide angle's not as good because I'm sinking. So therefore the the slope is something like this. Now where I take it to is where this line touches the curve, which is way down here. So this is now telling me at 0 lift, it says I should fly about here, which is a bit under 60, 56 knots. If I am flying at 3 knots, then I actually need to be cruising at this point, which is just over 80 knots. So with a 3 knot ring setting, so if you're going to get a 3 knot climb, it's going to tell me I should fly off at about 82 knots, not 56, which is where I got those numbers from for that previous example. So I'm much better off to fly just over 80 than I am to fly at 57 in that case. The interesting thing with this, and don't worry about this, you don't need one of these. You can have one of these in the cockpit with you and draw lines as you're flying along. That's an okay thing to do. You can probably set up an app on your phone to do that, but we'll actually show you a better way. Interesting about this stuff though is it actually tells you what your average cross-country speed is going to be. So where this 3 knot line crosses the 0 axis, it says about 45 knots, which is around about 80 kilometres an hour. So this says if I'm getting a 3 knot climb, then my average cross-country speed will be something like 80 kilometres per hour, 45 knots. So you can tell that data from the graph. So we're playing around with the graph and I look at a 6 knot climb up here somewhere, then it's going to be touching, invent this down here, it's going to be closer to 100 knots and the average speed is going to be closer to 110 kilometres an hour. And we'll see those numbers in a minute. So the graph gives you a lot of information. I don't ask if everybody understands that because we'll just move on. However, to find, we just mentioned this, stronger lift gives more sink. So it depends on your speed and the rate of climbing your next thermal. So we saw that calculation before. So if I know I'm going to get 6 knots, fly at 6 knot speed. If I know I'm going to only fly a 3 knot climb, fly at a 3 knot speed. And how on earth do I remember all this? Well, that's where Mr. Macready came in. Good man. And he invented the Macready ring. Let's go to the next line. That's what a Macready ring looks like. It fits on your vario and it points when the needle's pointing down, so it actually takes into account the rate of sink of the glider and the rate of climb, and it points down, and this is pointing with that rate of sink. It said I should be doing 45 knots in my 126, which is pretty quick for that. If I'm getting 6 knots of sink, I should be speeding up to 60 knots. So the needle is going to point at on this ring and tell you what speed to fly at. So you can get that. That's what the Macready ring does. And I'll just show you this on the FAA site. That's the original. Where was that? It was on the web page. We'll see what happens. Is that showing?
No, you've broken it again.
Don't know what I do, but I'm also
Windows P.
I'm good at this.
Thank you.
Now there's a whole heap of stuff in here about best glides that I've just spoken about. It shows you flying in sync. Shows you that if you've got a 3 knot or a varying sink rate that the glide angle reduces, and he then designs a, so there's the 3 knot ring setting, and it shows it flying at 60 knots because that's what you should do. So he then throw some wind into it, and he then creates his Macready ring. So identified he wanted something which was going to show him the right speed to fly based on the thermal strength and based on the performance of the glider. So from that graph I had before with the graph section above it, you can draw all sorts of lines, and Helmut Reichmann's book shows you how to do the bit, and you can create your own Macready ring for your glider. You can actually buy them as well, so it's up to you. So there's the Macready ring. As the vario changes, so does the speed. What he then discovered was that if you, rather than just put lines on the instrument panel, you put that on a ring which you can rotate. If you then rotate the ring so that instead of 0 being at 0, you've got a 3-knot ring setting, you rotate the ring so it's at 3 knots. And then at this speed here, you're going to be doing 60 knots because that will have moved around. So if you rotate the ring, it's going to tell you to fly faster the quicker you go. If you've got a 6-knot climb, you're going to rotate that ring all the way around to 6 knots, and then it's going to have you flying quite high speed, even in only 1 or 2 knots of sync. So that's what the McCree does. Just about to finish this section and we can do that. I think it gives me that. Blah, blah, blah. So there he is with his turning the McCree ring up to 3 knots, and you can do that on your instrument. How many people have got a McCree ring in their glider? About 2 or 3 of them. Okay. What happened to all the McCree rings? There is a cupboard somewhere in Australia full of McCree rings. Right? So they vanished for some reason. Why have they vanished?
Electronics.
The instruments.
Gives you beeps.
It's got a thing that beeps at you now. So they've actually upgraded this to something which beeps at you and says so you dial in and say I've got a 3-knot ring setting. Still use the same terminology, a 3-knot McCree setting. And it then does it all electronically for you. So it says I'm flying at 40 knots, it says you should be flying at 60, speed up. Or I'm flying at 90, you should only be flying at 60, slow down, and this thing beeps at you. So it was called a speed director when I first came across them. These days it's just the thing that goes beep. So it does it electronically for you. So you don't need a McCree ring if you've got a glider with one of those electronic gizmos in it. K8s probably don't, but some of the other things do. So the McCree ring stuff is told to you now electronically. So that's the reason what it's trying to do. It's trying to give you that information and just do it by saying fly faster or fly slower. You control that by setting the McCree setting. And just comment that when those McCree rings went to the electronic ones, what I saw is one of the most amazing sights. I think it's my first national championship. I'm flying along, I turn around, and this whole gaggle was after me. And I've seen them come towards me, and they were doing huge gyrations. There was gliders diving at high speed, and then they would pull up, and the wings would bend like this, and then they would bend like that, because people were following the speed director. If the speed director says you want 2 knots more, they push. If you want 8 knots more, you push. If you want 20 knots more, you really push. Now I'm hitting the thermal, I'd really pull to try and keep the speed director in the middle, because it was doing this, and had lots of sensitivity. So the gliders were doing this. It was great fun. I mean, you fly the glider and you got sick after a while, but it was reasonably efficient, except of course you were then creating a lot of drag with all those gyrations. There are still some pilots today that fly that way. You'll see them in some comps and they come diving past and then they go way up again. That's very old style. These days we try and smooth it out. So we've got speed directors now which do all this for you, and there's another way which is called block speed, which I will talk about briefly after we have a 10-minute break. Right, I'll just show you how to do the GFA forum.
Australia.
And also, if anybody hasn't put their name on this list, please, if you can do so before you leave, it'll be great. Thanks.
Those of you that are interested in the GFA forum, it is really simple to find. So there's the fantastic GFA webpage. And there's 2 places to find it. If you go to My GFA SOAR and click on that, the first thing you see is the Gliding Australia forum, blah, 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 blah. Click this link. If you do that, it takes you through to the forum and you can just say my name's Fred. I can't show you that because I'm already registered, so when I click on that it takes me to the forum rather than the register. And if that vanishes from there, you can go to Member Services, which is where you can get your GPC, where you can claim all your records and badges, and down the bottom you'll find Gliding Australia Forum. And again, same spiel, follow this link. So if you click on that, that will take you straight through to the forum. have a go, and if you can't have success with that, call Mandy. Or you can call me.
Yeah, if you want, I can just sign everybody up that's on the list. If you want to do that, let me know.
Okay, here's our famous polar curve of a fantastic glider. In terms of all those calculations with the lines, you don't need to do that. I just thought I'd show you how to do it. Speed to fly. If you click on your particular glider, it shows you down here for the rate of climb you've got, you should fly at this speed, and your average cross-country speed is going to be this line. So if you've got an LS3 at 35 kilograms per square metre and you're in a 3-knot climb, you should cruise around about
On the right,
hey?
on the right, I think.
No, 3 to 5 water.
Speed to fly knots. Alright, 3 knots.
Kilometres on the right is the
Okay.
units.
Yeah. Average speed kilometres per hour. Oh, this is
That's for the left.
this is the speed. Sorry, wrong line. This is the speed. So if I'm kind of 3 knots, I should cruise at 80 knots, and my average cross-country speed will be 80 kilometres per hour. If I'm going to get 6-knot climbs, I should cruise at about 88 knots, and my average cross-country speed will now be about 110 kilometres per hour. Hey?
That's horrible.
What? 35 kilo. Okay, you can't even get your glider to 35 kilos per square metre, can you? Now, if I multiply that by add 10% to that, it's a lot better. Oh, here they come with their, oh yeah, my glider does this. Well, if that's what you reckon. Here's some statistics from the Uvalde World Cup, so bear with me for a second. Let's take we'll take 18 metre class with ASG 29s and that sort of stuff in it. So I'll just scroll down a fraction. Scroll up a fraction. So you can see the names of the pilots: Dave, Tom, Wojcik, and Termat, Polish guy, Termat. They were getting to about 9,000 feet, if you look a bit higher on the open class guys. Here is their achieved cross-country speed for the day, and here is their achieved rate of climb. Right, so around about the 6 knots, and they're doing about 150, 343 kilometres per hour, compared to the 110, 120 that the LS3 was showing. A little bit heavier. You'll also see that the glide angle being achieved is 88, 82, 104. Now that's a little bit higher than the catalogue says, okay? And that's the bit we want to talk about next, is if the catalogue says you can do 42 or 48 or 50 or 60, how come they're getting glide angles like this? You'll see their cruising speed is around about the 94, 95 knots. This one is a bit slower, but glide angle a lot higher. So that's the comparison. So you can see for 15 metre gliders, the speeds are around the 135 kilometres an hour mark on that particular day. So I'll come back to that in a minute for another reason. But coming back to our speed to fly thing. So for that, you can look it up for any glider that's on their list. So if you want to see it for a LS4, then the speeds are slightly lower. See it for whatever else. So whatever you've got on there, if you have a look at that list, you might be able to find your particular glider, and you'll get that. The cruise chart is probably the most interesting, because the question comes, so if it said I should fly at 80 knots with a 3-knot ring setting. Well, I mean, we already know that if I hit more sink, I'll fly faster, and so McCree's going to tell me to go a bit faster or a bit slower, so it varies. What happens if I vary my speed? So this graph is showing if I've got a 3-knot, 4-knot ring setting, in the orange one, the average cross-country speed in kilometres an hour if I'm cruising at 70 knots, is just under 80. If I cruise at 80 knots, it's a bit over 80. If I cruise at 90 knots, it's a little bit more than that, so it's about 82 or 83 kilometres an hour. So you'll see here that what speed I cruise at impacts on the achieved cross-country speed, but not by a large amount if you're within a narrow range. If you look at this range here, so this is for the 1 knot climb, anywhere between 80 knots and 60 knots will give you about the same answer. Will give you about 40 kilometres per hour average speed. So it doesn't matter what speed you fly at within that range, you'll get the same answer. I fly a bit faster, I sink a bit more, climb a bit more, I'm getting only 1 knot climb, so it's going to take a while, but it works out about the average. If I only fly at this speed, then my speed's a lot less, and if I fly too fast, my speed is less. Now if you take it up to the say a 6 knot line, you'll see it levels out up here above between 90 and 100 knots. So if I'm cruising at only 70, my speed is 85. And if I'm cruising at about 95, then my achieved cross-country speed is 100. So that all seems very low, but they're the sort of numbers it's coming up with for that. So the key thing here is that if I don't get my speed perfectly right, if I'm not following that McCready, if I'm doing the big zoomies following the speed director, you're wasting your time, because it doesn't make much difference as long as you're somewhere near the ballpark. If you're within 10 knots either side of it, then the optimum, then it's going to be much the same performance. So you actually don't need to follow McCready or the speed director that closely. Now that's good news, because if you do try to follow them closely, you spend your whole time doing this instead of looking out and seeing where the lift is. Right? You focus so much inside, reading the instruments, listening to the beeps, pulling and pushing, feeling sick because of the G-forces. Whereas if you actually just pick a speed in here somewhere, close to the optimum, then that gives you a much better situation. You can see that. So what we do is we can turn, rather than a McCready ring and our speed director, we can actually come up with what we call block speeds. So we'll see, I'll do Control P. No, it worked. I'll do the, just kill myself with that stick. Right in here. Oh, it worked. Fantastic. So here's, based on that information for the LS3, I've got 1 knot cruise speed, 1 knot climb. I should cruise at 70 knots, give or take 10, and I will achieve 39 kilometres per hour cross country. Wow. However, if I load it up with water, I've done the add 10%. Over here, I'll cruise at 77 knots, give or take 10, and I'll achieve 44 kilometres per hour. So, and you'll see now here, down here at 6 knots, I'm cruising at 105 knots cruise speed, or 115, and I'm achieving 110 or 120 kilometres per hour based on those numbers. So that's a table showing the same data. So it's probably easier for me to have this table in the cockpit with me as an indicator of speeds than it is to have the graph and draw the lines on it, or to have the Excel spreadsheet and sort of read off the thing. So a table like that would do that for you. And in fact, you can simplify it a bit. And we go wick, 1 or 2 knots, cruise somewhere between about 40 and 60. I might choose 60 because I like flying a bit faster. Actually 60 is not good, 58 is good. If it's empty, if it's medium thermals, 3, maybe 4 knots, I need to be cruising up closer to 80 to cruise speed at 90 knots. I'll achieve 90 kilometres an hour. In stronger weather, I'll cruise at 100 knots. So this is telling me in the LS3 empty, I'm going to be cruising somewhere between 75 and 100 knots. If I'm full, between 80 and 105 knots in those sorts of climbs. So That's a much more simple table to have. I've seen variations of that table where it shows if I'm high I do this and if I'm low I do that. And that's just the fact that there's a range of speeds here. If 65 knots doesn't make much difference to the achieved cross-country speed and you're not getting very high, then maybe 65 knots is better because you won't get as low. The slower you fly, you're risk averse, you don't get low very often. So if it's all a bit weak and it's very low, then you probably want to err on the slower side of that. If you're getting up 5, 6, 7, 8,000 feet and you're starting to feel pretty confident, bit of queue ahead, you're having a good time, then you can go to the higher speed ranges here and add an extra 10 knots to it. It may not improve your cross-country speed much, but all you need is one good climb and all of a sudden your cross-country speed goes up. The one thing I didn't point out with that multi-layered graph, I won't pull it back because I'm too scared. It does that. And you saw there, a 10 knot speed difference doesn't make much difference. A 1 knot climb improvement makes a huge difference in your cross-country speed. Here's your cross-country speed. So you fly 10 knots too fast or too slow, bugger all difference. You get 1 knot rated climb increase, you get a much larger difference. So if you actually get the climbs, that's how you can increase your cross-country speed. The cruising bit is really just the fine detail around it. So you've got to increase your rate of climb. Sometimes flying slower does that because you don't get lower, therefore you can be more selective, etc. So get an increased rate of climb and just be a bit conscientious with the speed, but you don't have to be too precise. So now you've got a table like that sitting on the side of your cockpit. You no longer need to be following the beeping and the shoving. You don't need to be twisting your ring, and you can just cruise off. Now you can focus on what's really happening. You can look outside. You can feel where the air is going and so on, and actually do some real cruising. Any questions on the table? And that's easy to set up for your glider. In fact, they're all much. And I'll put a bit of reality into this. This is my data. So this is Terry being self-revealing. So over a period of time, this is the sort of average cross-country speeds and cruising speeds and rates of climbs that I'm getting. So interesting to know, I always work on that, it's a 4,000 foot day, you're going to get 4 knot climb. 6,000 feet, you're going to get 6 knot climb. So I was interested to know how true that was. It's not quite true, and maybe that's me, but I find it's about a factor of 0.7. So a 5,000 foot day, typically the thermals are stronger because you're getting higher. I typically on a 5,000 foot day will average 3.5 knots rate of climb. And my cross-country speed will be 100 kilometres per hour because of that. If I'm getting a 6 knot rate of climb, so 8,000 feet or so, I'm averaging 6 knots, my speed is around 135 to 145 range. Is the average that I've done on those sorts of days. So this gives me a good indication when I'm doing assigned area tasks or setting myself up for the speed task, what time do I leave, etc. What speed am I going to do? They're predicting 7,000 feet. I should expect about a 5 knot average rate of climb. And I should expect to do 126 kilometres an hour in the LS3 with maximum weight. Okay? So you can get that sort of data by analysing your own flights. How does that compare? Here's the theory. So 5 or 6 knots, it's this one, 8,000 foot day. I think that's deemed to be strong on this factor. This said I should be cruising at 100 knots. I don't have that information here. I should average 100 to 110. Now I'm flying, it's about 130 something. So I'm actually achieving a fair bit more than the theory says than I should. If you look at a 3.5, call it a medium day, it says I should be doing, say, 90 kilometres an hour, and I'm doing 100 kilometres an hour. So I'm doing a bit more than that. So these are conservative numbers. Why am I doing more than that? because the glider actually flies according to, as a measured polar. So why am I doing more than that?
Kicking.
Cheating? Yes.
Check his profiles.
Yes.
Finding better air.
Finding better air. So if you actually cruise it better, now imagine that polar curve. What happens if I won't go back to the pictures, it's too hard. If the polar curve is like that, if I actually fly through consistently half a knot of positive air by flying under the clouds or flying under the streets through one way or the other, if I can get a half a knot air mass improvement, half knot's a bit hard to find, but it's possible. What it does is it actually drops this line half a knot. Depends. Yeah. Now all of a sudden the glide angles are suddenly a lot better. So instead of the glide angle being, say, like
Hang on.
instead of the glide angle being black one work. Instead of the glide angle being, say, from here, instead of the glide angle being too many things, I'll hold your glasses and do all this. Instead of the glide angle being like that, the glide angle is now half a knot lower, the glide angle is like that. So I'm flying a bit quicker here, and my glide angle is a lot flatter. So instead of achieving one in 40.4 or 38 or wherever it is at the various speeds, I'm all of a sudden going to be getting a better average glide angle, which means I'm not going to lose as much height, which means I'm not going to have to thermal as often because I'm not low enough to thermal yet. I'll take fewer thermals, so there's less mucking around. And when you're not very good at thermaling, it helps not to take too many thermals. So I can actually fly in air, which gives me a net vario reading. I can find a thermal which gives me a net positive vario reading. There's actually a setting on a number of instruments called netto. And netto is actually what it subtracts the rate of sink of the glider for the speed you're doing and says this is what the air is doing. So even if you're doing 90 knots and the glider's sinking way down here at about 4, then it takes off the bit of the glider and says, right, you're actually starting from here, or you're starting from here, or you're starting from here. It actually tells you what the air mass is doing. And I find that really useful when I'm cruising to know whether I'm actually in positive air or if I'm sinking air. If you're in positive air, you've got a much better chance of getting a flatter glide angle. Remember the Uvalde stats just before? The glide angles being achieved by the 18-metre gliders were around the 80 to 100 to 1, which is about twice, 1.5 to twice what their perceived glide angle is going to be. So therefore that's why they were able to get much higher speeds up around the 150 mark compared to what the theory says they should probably be doing about 130 or something like that. So better cruise gives you much better performance, and that's not by flying faster, it's by actually flying in air that's going up, which impacts on your polar curve. So does that connection make sense? What thoughts or questions have you got about that?
How do you find it?
How do you find it? That's a good question. I want you to answer that. I'll come to that in a second. But yes, if you can actually achieve that, then all of a sudden your cross-country speed goes from, gee, I wish I could reach 100 kilometres an hour, to, I wonder how much above 120 I'll be doing today. So that's a fine difference. Rule number one, you need to be able to climb faster, because that makes the biggest difference, as in here. You can climb 1 or 2 knots faster, you will go a lot faster. Once you've got the climb right, then if you can get the cruise better, then you will end up even faster again. So there are two things to focus on. So I'm conscious of the time. So cruise considerations. It's just a list because it's going to take too long otherwise. Fly the correct speed. Now, when I say what do I mean by the correct speed?
The block speed, what?
The block speed, yeah. Fly the block speed, or fly something in this sort of level band of the polar curve. Fly the speed that you reckon is reasonable to fly, 60 to 80, 80 to 90, 90 to 100, whatever. Make sure you're flying that. Because if you fall off the back end, this bit here, a number of people I fly with, that they climb up really well and they head off, and after a while you sort of say, well, you're going to speed up. They're still doing 45 or 50 knots. And we're cruising along at 50 knots in the cruise looking at the next thermal. The problem is they're operating in this section of the line where the cross-country speed is dropping off rapidly. So you can't operate back there. So if you don't do anything else, when you leave the thermal, at least go to your nominal cruising speed. Right? 70 knots, 80 knots typically for most people. So that's the first mistake to make. Don't do that because that will impact you greatly. And when you hit the thermal, you get bugger all the pull up when you're doing 50 knots. If you're doing 90, you get a big pull up and it's G forces and it's great. Okay. The other thing is to keep flying there. Oh, I get into this now, I'm doing 100 knots, I'm going to fly at the top end of this, and you go barreling through the next 3 thermals, not even knowing they're there. All right, so as you start to hit the buoyant air, you do need to back off at least to the back end of this range to give yourself more feel. All right, at 100 knots, the glider's quite stiff, and you're not really going to feel the small nuances. Oh, there's a bit of lift over this side, or there's a bit of lift over this side. 100 knots, you're just going to go, what was that? Okay? So if you back it off a bit, especially if you're getting lower and you're starting to think, oh, I wouldn't mind a climb about now, then you need to be backing off a fair bit more. So don't go barreling through thermal air, fast through thermal areas. We all know the stories that Bruce Taylor never slows down below 80 knots in cloud streets, and I've seen that and I've flown with him in that. And that's true some of the time, but it's not all the time. So you do need to make sure that you slow down to a speed that's going to give you some feel and give you a chance to react. So, oh, there's a bit of lift on the right, I'll move that way. Oh, here's a thermal, I'll slow back now to 60 and 50 knots and start thermaling. If you try and do that from 110 to 50, it's quite an abrupt pull-up, and you'll lose all feel of what's happening. So fly according to your block speeds. So if you've got your little list, little table, fly along at those. Fly through rising air. The glide performance better, the low risk, and the few thermals required. How do you do that? The couple of ways. One is you select a track that optimizes rising air. Again, visible clouds help with that. So you actually need to be looking out to do that and looking outside. I find some people never look above themselves, they never look at the clouds just here, and they're wandering along and you sort of say just a bit more to the left, a bit more to the right, and they're not flying underneath the middle of the cloud or the dark part of the cloud, they're not looking where the cloud is, and then they head off in some random direction. And yet if you look far enough ahead, you'll actually see the line of clouds, the clouds that join together. You can put dotted lines against the clouds, and that won't work. So clouds is easy. Not much talking about them in South Australia. We get there every now and again. And if I have to travel from here to here, I can do that. If I actually look out and look 40, 50, 80 kilometres ahead, you can see the cloud shadows, you can see the clouds. You can then start to say, what's the best line that's going to get me there? Because the more thermals I fly under, the more lift I'm going to fly in, and therefore the average sink rate that I fly through is a lot less. In fact, it might even be rising there. So from here, we can try joining the dots. Which way would you go? Diggy, you're the expert on this. Come and join some dot. These are clouds, okay? Square thermals, yeah. So go from there to there, flying under as many clouds as you can, within reason.
Just go this way. And you can go that way.
Yeah, good thinking. Thank you. Give him an applause. Hey, hey. Okay, very good. So you're actually going to look for lines of cloud. Now there's a bit of a deviation there. What do you think about the deviation?
Well, it depends how long the leg is that you have.
Yeah, that's 80 kilometres, that red line.
You can do quite a deviation.
Pardon?
You can do quite a big deviation and still get there faster.
Yes. Yeah. So the deviation bit is not a major problem. You talk to George Lee, who's been a world champion 3 times. He doesn't like a deviation more than 30 degrees. And I actually still feel nervous having heard that, but every time I deviate, I'm flying along at a 50-degree deviation thinking I shouldn't be doing this, but I do it anyway. So the...
And the wind direction.
Yep. So the blue one gives me much less deviation. It gives me 3 clouds. The black ones give me 4 clouds. So again, depending on what the air is like in between and how high you are, you may decide that the blue line, the shorter distance, is a much better example, and you put up with a slightly less amount of lift. The black ones will give you a greater potential for finding better climbs. If I take this route, and then a beautiful cloud forms just here, which wasn't there before when I first started this, and I've taken this route, I'm going to be really peeved, right? Because I've now gone all this way around. The guy following this line, or the blue line, has got a much better options if something happens. If the thermals start vanishing, then we've all got the same problem, but if something suddenly starts to change, then closer to straight is better. If it's not much of a deviation, then you're better off going closer to the line than to go to the extreme. So you need to be able to follow through the clouds, and that's going to give you a much better chance. But to see that, you do have to look 80 kilometres ahead. Right? You've got to look where the cloud, you've got to see where they line up, and you'll find that even if there is blue air between, so these are not there, but you've got a nice cloud streak running here. I'd love to get to that. Even through the blue air, you'll quite often find that that cloud streak keeps going in a straight line. So if you can actually see the cloud streak ahead of you, then you can join the imaginary, the virtual cloud streak before you get there, and you've got a good chance of actually finding, there's probably still lift there, it's just not forming clouds. So if it's forming a line there, it may be continuing that line. I find that quite often. So looking well enough ahead to see where the clouds are, where do I want to hit that cloud so I can get to where I want to get to with the best amount of lift. If you've got clouds, that's a bit easier. If you've got a blue day, then you've got 2 options. You fly a straight line, as in the red one, and hope you bump into something. Or you actually start to use feel for what's going on. And that's a little bit harder to do, but it's certainly worth the effort. So as you glide off on this blue track, as you're feeling along, you're flying at a speed, maybe you fly a little bit slower initially. If you start to feel a bit of lift over this side, it's worth deviating towards it. And if it keeps getting better, you keep deviating. And then it stops, and then you turn back a bit more on track, and then it's getting better this side. You actually find that you end up doing a bit of a guided tour on the way to your track, but quite often you're flying through very positive air mass. So that deviation, can I feel the air? Can I feel what it's doing? You're doing 110 knots, that's a bit harder, but it's still possible, depending on your glider. Maybe fly at the slightly slower end of the speed range to give you a better chance of feel. What's the advantage of flying at the slower end of your speed range on a blue day like that? There's height loss. So you're going to end up not getting quite as low as often if you're at the slightly slower blue end. The other side, of course, is if I find that 10 knot climb at 2,000 feet above that brown paddock over there, then I'll be much better off. So it's your decision to make on that. So trying to find the air either by visual cues, lines of brown paddocks with willies in it, ridge lines, etc. All of those things will give you a choice in terms of track. It may not help you, it may make you feel a bit better, but typically it will help you in terms of your glide. How do I go for time? Am I run out?
Terry, if you had a crosswind, would you deliberately go into wind? Do you consider that?
Yeah, if I've got a choice here of, if I've got a wind from that direction and I'm here, I'm better off to take this track, because if I do get low or need to take an extra climb, then I'll drift towards it. It's nothing worse than going this way, you're way downwind, and then all of a sudden you have to take a 2 knot climb, and by the time you get up, you're way downwind, and you've got this big long lead into the thermal. It's very important. I mentioned the netto. Feel the air is important. I mentioned netto. People land at turning points. That's what they do. That's what they do. They all fly to a turning point, and that's where they land. Why do people land at turning points? Because they can.
You should go in as low as you did.
Right, depends on which way the wind is blowing.
You've got no choice, you've got to go there.
Yes, so it may be in all these clouds, you've got this big blue area out here, and that's where the turning point is. And that's where you're going. So that may not be an option. Bruce says if you've got a strong headwind, you're much better to go there low and then get a weak climb climbing away, rather than taking a weak climb before you get there and drifting away and then have to fly that distance again. And the other reason is that people start to focus on the turning point, and instead of following the lines of air, they fly in a straight line all of a sudden. Within 15 kilometres or 18 kilometres of the turning point, they fly a straight line towards it, and they're flying through the sink, and they're ignoring the nice little cloud street. So if you're here and the turning point's there, and this is 15 or 20 kilometres, it is worth deviating like this to get there, not flying 15 kilometres straight into the turning point and landing there. So people tend to get a bit fixated on the turning point. I don't think I have enough time to do final glides.
Fairly soon. So what else did you have there?
I just had some stuff on final glide. You want me to cover this very briefly? Just some thought starters for you, or you prefer to talk a bit more about the cruising bit? A bit of final glide. All cross-country flights end with a final glide. Okay, so even before he landed out on cross-country flight, his 500k but landed a bit short away, he still did a final glide. It just wasn't the same final glide he was imagining. But you eventually do one, and the key thing there is to do it safe, because if you're fixated on I want to get to that point and I don't do it, then you can cause yourself some problems down low. Competition flights have a final glide, and pilots tend to push it a little finer. So they start to refine their approach in terms of getting there. And again, the need is to do it safely. So there are conservative ways to do final glides, and there are aggressive ways to do final glides. I'll talk about the competition one because that's probably where it becomes more important. If you're doing a badge flight, the key thing for you is to get home. You don't care whether you're 5 minutes late or even 15 minutes late. You just want to get home back to where you started from. So for you, a final glide, the important thing is to be very conservative and be very high and do a path trajectory, which looks something like this. So this is ground level. Here is the straight glide to home. There's a few trajectories you can follow. You can follow this trajectory, which is you stay above the glide angle, so you're fat, dumb and happy, having a good time. The other more aggressive one is that you start from here and then you try and pick up, you try and pick up, you try and pick up, and you get there. Okay? A more aggressive one. I used to do a lot of the very aggressive ones, and I scared myself a few times, but they are really good in terms of a fast final glide. But you need to know how scared am I prepared to be. And when you've landed a bit short a couple of times, that starts to make you rethink what was the benefit of one versus the other. So you're going to have, if you're going for a badge flight and you want to get home, you take the conservative route. If you're in a competition and here you are and you can't find that last thermal, you may want to be starting to look at a more aggressive or less risk averse thing. When you do a final glide, that black line is interesting because here you do 33 to 1, which is not too bad a glide angle at 80 knots or something like that. That's not too bad. It's 10 kilometres per 1,000 feet. So when all my instruments fail or I can't work out what I'm doing, I'm 40k out and need to be 4,000 feet, and then I add a little bit, just in case. So 10k per 1,000 feet. So there's that black line I've got down there, the cruise down to the ground. The problem with final glide and final glide computers and that sort of stuff is they don't see the trees. And the thing is, your glide is never constant in the glide. Sometimes you're sinking and sometimes you're rising. So in actual fact, the black line is your desired glide path, but it will actually be something like that. So there'll be times when you're above it and times when you are below it. The problem is when you are below it at the last bit, then it starts to get a bit fraught. So if this bit is like this, then chances are you won't make it, right? Or you're going to scare the living daylights out of yourself. So you're taking too high a risk. So we actually put a safety height, a safety margin, and most people put that in. I know I do, Peter does, I think. So most people put in a safety margin. I put in 500 feet, some people put in 300, some people in 1,000. Some people don't put any, but they add it in mentally. So you have some sort of height which is going to take care of these variations. So you jack the whole line up by 500 feet, and that then it lets you do that sort of approach at the end. So it is worth having that safety height. When you start off, I would add 1,000 feet in there. It's what height would I like to get back to the airfield and still feel very comfortable that I'm going to handle whatever comes across me. And that's a reasonable approach. So the profile you get, the best glides I've done is when I've started off 6,000 feet out 100k away. 6,000 feet below glide 100 kilometres away. And you don't thermal all the way home because you've got a nice cloud street ahead. You find that you're rising through buoyant air. You see I'm 6,000 feet below, glide on a bit more. Oh, now I'm only 5,000 feet below, and glide on a bit more. Now I'm only 4,000 feet below. You start to say, this is getting better. It takes me a while to work that out, but you can see it getting better. So you then do this approach where you can consciously start your final glide lower than you need to be if you're getting good air. If you're not getting good air, if you're actually getting sinking air, I'm 1,000 feet above, I'm 500 feet above, I'm 500 feet below, I'm 1,000 feet below, you're not going through good air. And your chances are you're going to keep getting that poor stuff all the way to the ground. So when you're starting to make that realisation, you know you must find a thermal. So I'm very conscious of final glide 100 kilometres from home, because I need to know whether I'm picking up on glide, whether I've already got glide, or whether actually this day is not all that good. I need to be very conservative and take the really super conservative approach, or the one going the other way. With the Uvalde stats, I won't bother flicking across. One stat which came out quite clearly, I had the time it took you for the first 50 kilometres, and the time it took you for the last 90 kilometres, which is the final glide, basically. I wanted to make sure it included a climb. And people were making up 5 or 10 minutes on the whole flight. They would lose a flight by 5 minutes, and all of that was lost on the last climb. Right, either getting too low for the last climb, not following the right path, being too aggressive or too conservative with that final glide. So it can make a big difference. So you need to look at some of those. The guys that are keen on the competition bit, I'm quite happy to talk more about the more advanced aspects of that at some later stage. Again, maximise your glide angle. So like going to the turning point, I'm on final glide, I've gotten just enough height, don't just fly straight. If there's a little cloud street off to the right, go via it, because you never quite know what's going to happen. So you take those conservative options all the way in. Even if you're in the last 10 or 15k, you can lose it all in the last 10k if you're not careful. So take that conservative. And the important thing is know when to call it quits. So if you suddenly find that you are coming in and I'm getting worse, I'm getting down below glide, etc., when do I do it? Then you need to know when to stop. Brian and I did that at the last 2 SETA nationals, and we didn't quite stop early enough to climb up. We couldn't climb up, there's no more thermals, but it just all stopped at the end. So we couldn't quite make it back. And you need to know when that's happening so you can do a proper safe landing. So know when it's falling apart and do something about it positively, and then you can talk and have a few beers and talk about it at the end. So know when to call it quits and follow those sorts of stuff. The one thing that is important is that if you've got a 4-knot ring setting, which says I'm getting approximately 4 knots of sink average over the task, or I'm a bit below glide now, I'll turn my ring back to 2 knots. I'll go to a more conservative speed. That's not going to help, because your glide angle is dictated by the rate of sink that you're getting, and just by flying a bit slower, you've just moved yourself along this line a bit, but you're not changing your glide angle. So just turning the ring back isn't going to get you home. You need to find another thermal. So that's the key thing with that. Now we're doing it, I've run out of time. Any questions on that? I can take a couple of questions.
I was wondering about the Gawler maritime replacement there, if you had any special.
The
and Stonefield and Alpha.
the South Australian maritime replacement there, which starts from many places. It can be your friend. It should also dictate the polar, the profile of this flight. If you're flying back into Gawler or Balaclava or even Stonefield, if you're coming from the wrong direction, if you're coming from the east, for example, you've got to cross the Murray River and go to Waikerie from this side, you've got the same issue. You can go through sea breeze. If you come back to Gawler, you definitely will have a sea breeze, and probably into Balaclava as well. You'll definitely have a sea breeze. You need to be aware and conscious that it happens most days. There are some days when it's bleeding obvious it's going to happen. Sometimes you can see evidence of it, but quite often here on blue days in particular, you've got no idea until you blunder into it. Realise that it will be there. If you don't want it to be there, it will be. So your profile needs, you need to have a glide angle from about 40 or 50 kilometres, you need to be above glide. And so your aim there is not to get to a final glide to Gawler or Balaclava or Stonefield or Waikerie. It's how do I get to 5,000 feet at Kapunda, or how do I get to 5,000 feet at Clare before I fall into the sea breeze. So do your final glide to that point, and then it's a simple glide. If you don't achieve that, if you're down here, then the chances are you're either going to work some very weak thermals into a headwind, if you're lucky, or you're going to end up about here somewhere, on the ground. So it's conscious. When I came back from one of my 1,000k flights, I left Waikerie, I think I was 135 kilometres out at 10,000 feet, which is not enough, 10k per 1,000 feet, but I flew slowly. And then you could actually see the edge of the sea breeze coming up the Murray, between the Murray and Stonefield. And by deviating slightly, I was able to fly along the edge of that. It wasn't booming lift, but it was buoyant air, and managed to pick up. Didn't increase any height, but I didn't lose height for about 20k. And that all of a sudden makes a huge difference. So you can come home, if you're aware of where the sea breeze is, you can utilise that sometimes, if you can spot it. So, other questions? Final one. When it's done perfectly, you'll be at your normal cruise speed all the way in. You won't be coming in at 130 knots, unless you've been cruising all day at 130 knots, which I doubt. You'll be coming in at your 90 or 100 knots, or whatever it is, 80 knots. The only bit of excess speed for doing a low-level finish is through this slightly steeper approach because of your safety heights that you've got involved. So you won't normally be coming in at 130 knots, 140 knots. That would be quite rare, unless you're just happened to fortunately fly through some buoy and lift on the way in.
Terry, if you were say, let's say you were 100 k's out and the instruments are telling you that you could have gone and glide, if you flew your block speeds like you're talking about, there's a good chance you probably won't make it at that, at that speed. Would you slow right back down to maybe say, like if you're meant to be flying 90, would you fly 70 and just keep going? Would you push on at that 100 knots and then say, well, I'll get till I'm 60 k's out and then I'll reassess that?
Yeah. Unless there are other indicators, I would fly at the block speed that I'm flying at. The only reason I would back off, as you suggested, to say 60 or 70 knots, so that Wakery day I left there, 11,500 feet, there was no prospects, so 1,000 k day coming back from the east, there was no prospects really of finding more lift. It was late, and I just wanted to maximise the glide, and I found buoyant air. So that, then I was gliding back at about 65 knots. It takes a long time at 130 k at 65 knots. So the flying at that lower speed just to extend the glide. But if there's no more lift, then the best LD speed is the right one to fly. But if it's a normal cruising day and you've got the required height, you're 10,500 feet or something, 100 k out, I'll be fairly confident that I'm going to, again, by choosing a path through the air which is going to give me more buoyant air, so along the ridge lines or if a bit of Q, if I can see a sea breeze deviating or whatever, if I can fly through a pathway which is going to give me more buoyant air, then I know that I'll get the glide angle to get me home. Or I'll find a thermal. Typically the last 100 k should be fine. The last 30 or 35 or 40 k coming into Gawler can be fraught with sea breezes, then you're probably not going to find anything unless the sea breeze came very early and the thermals are restarting.
So say you're on final glide, on the black line.
Yeah. Top black line or the bottom black line?
Comfortable flying your block speed final glide, and you run into a thermal. How strong does that thermal need to be to shorten the time taken home?
Remember with McCready that we said you need to base your speed on the next thermal you're going to get. Okay? Final glide is good because you're not going to get a next climb. You actually base your McCready on the climb I've got right now. So if I've got a speed of that will do. If I've got I've been getting 4 knots all day. I've been cruising at about 90 knots. I'm getting 4 knots, then I'm on final glide. It's working out. The numbers are going down well, and I now hit 6 knots. Then I can now afford to cruise at 100 to 1, which is going to give me a much steeper final glide. So it's actually worth taking those numbers. So if you dial into you should dial into your final glide computer, which is going to be more accurate numbers. You should dial into your final glide computer the rate of climb you got now. So I suddenly find an 8 knot climb out of the blue. I get 8 knots and I've been getting 4 or 5 all day. Then dial up to 8 knots and see what it says. And it gives you some ridiculously high altitude that you're going to need at that speed. And you'll come home at 110, 120 knots and all the way. Theoretically, that's the best option. Sometimes in practice, if you're in a competition and you're coming back and you leave the thermal, the person who starts final glide first wins. So unless there's a really good climb. So if you're with a group of gliders and you've got 5 knots, you've got 4 or 5 knots, and you hit 6 and you start climbing it, and it's slowly growing to about 7 or something. When you're comfortable with your 6 knot climb, if you can leave straight away, then quite often it works out for you. So it's somewhere between what you've got now but you can certainly go up to the maximum based on the new rate of climb, because you know what the rate of climb is.
Yeah, Terry, I found quite a few years back when Bella Club had the regattas and was flying the club's discus, and John Dennis had his LS4. We were both together at the final thermal. It was about 2 knots. JD called up out on final glide now. As soon as he left, it went from 2 knots up to 4 knots. So I wound the McCready ring up to 4 knots, because I had just got there a while ago, you know, just like before, went up to 4.
That's double.
And overtook my final glide another 500 feet above him, and I arrived about 2 minutes early before him. That was from Spalding to Balaclava.
Okay.
So that made all the difference.
That's quite a significant
and
difference.
That's, that, you know, that really to me proved the significance. You know, use your thermal strength as your ring setting.
Yes. But as soon as it starts dropping below that, you've got to let it.
You've got to go.
You've also got to realise that climb rates, they're a rate of change. So the difference between 1 and 2 knots is double, 2 and 4 is double, and 4 and 8 knots is double.
Yes. Yeah, so it's quite significant.
So
5 to 6 isn't it?
5 to 6 knots, it doesn't matter. It's 1/6 difference.
Okay. Up there.
Yes.
It's starting to get a little bit late. So, thanks Terry, it was a very informative, thanks for giving away all your secrets. You realise you haven't got a chance in competition.
Yeah, I know.
Now I know he's cruising.
All the young guys keep beating me now anyway. So.
Anyway, if you can, I'm sure your family probably is.